The vertical MOA average was 0.966, so almost 1 MOA average of vertical. But from group to group, the center of the group shifted 0.448 MOA. So from one group to the next, like one group was here, I had that big rectangle plate. I measured from the top of the plate down to the center of the group, and then shot another group, and it was almost half an MOA lower. So it's not just about the group size, and it's not just about how much vertical the group shoots. It's from group to group, how much is it moving around, and that's why maybe we derail here and talk about this. That's why with my abbreviated load development method, the 10-shot method, that's why I care about the bullets, the sequential charge weights hitting in the same place, is that I want to know, like, across a certain velocity band or across a certain temperature band is the same way of thinking about it, because that's what you're checking. When you have multiple charge weights in a row that hit in the same place, that's the same as the gun shooting in the same place at different temperatures. There's no difference. So when you have sequential shots in a row that hit in the same place, that means that whatever hand load you find at the center of those charge weights is more likely than not to not have a lot of vertical shift. Now, you can still get vertical shift, but in my experience, doing it that way, actually being concerned about where sequential charge weights hit relative to each other, more times than not, if you do that and you make that a priority, more times than not, the vertical shift of the ammo is going to be very minimal. And that's what you want, because you see, like, this ammo didn't shoot well, but you'll see in later examples, sometimes the vertical shift can be just as much as the original vertical average. It's like if it averages this and it shifts the same amount, well, now you're twice as worse off on my grading system. And your group is, theoretically it's twice as high, because if it's this big but it shifts the same amount, well, now it's double. It's not what you think it is, it's double. So you need to be checking this stuff. It's really important.
Hey boys and girls, well, today's the day. It's early August, and we're finally out here ready to stretch out the factory ammo and our hand loads as they currently sit. We're out at the farm today, and we're going to be shooting 640 yards. Why 640? Because that's where the landowner lets me set up a target and leave it there all year, so I never have to move it. And it's close to that 600 yard mark that we talked about as kind of our outer limit for ethical long range hunting. So that's where we're going to test, is 640. It's a little farther than 600 yards, but that shouldn't matter all that much. Today we are going to shoot 7 Rem Mag and 7 PRC, and start with the 7 PRC, which I would say, if it's been shooting great, but I would say if anything it's kind of at a slight disadvantage, just because of what's been going on in the industry. It's been kind of unfairly propped up as the Messiah cartridge when it comes to big game hunting. I've had enough time to play with this thing now. Try not to get zapped here by the wire. It's a fine cartridge, but when you pile unrealistic expectations on anything, it's easy to be disappointed. So I haven't shot this yet at 640. I shot it a little bit at 4 1/4 when I was doing our promotional video for our Thoroughfare tripod. I'll link that video in the corner. Check that out. But other than ripping a few shots at 425, I haven't shot this gun past 100 yards. So curious to see how it groups at 640. I'm sure it's going to do just fine, but like I say, if it doesn't, doesn't live up to the hype, I don't know what you guys are going to have to say about that in the comments. But then we're also going to shoot 7 Rem Mag. So that has been shooting really well also. Not quite as good as a 7 PRC at 100 yards, but you know, when you shoot at long range, you're dealing with wind, a lot of other conditions that can affect how the shots disperse at distance. So the two rifles are shooting similarly enough at 100 yards that one could easily outshoot the other at 640. And it wouldn't surprise me if the 7 mag shoots smaller than the 7 PRC, just because it's kind of within the margin of error at 100 yards that you know, one could shoot better than the other. So just gonna grab the tarp here and get set up so I'm not laying in a bunch of stickers and thistle. The landowner just mowed all the thistle. It was, that's a milkweed, but you can see the thistle here. It was all like chest high, so he was coincidentally mowed recently, so I don't have to deal with that. But I'm gonna get the tarp, get set up, and then we'll make some racket.
All right, so a couple things about the shooting session before we get started. I ended up not having time to shoot the 7 mag that day, so I ended up having to shoot that at a much later date. The 7 PRC, with how much I was shooting, ended up taking a lot more time than I thought it would, which isn't a big deal. But so we just ended up doing the 7 PRC that day, and then the Hornady Outfitter 160 CX ammo, when I started shooting that, it was behaving really erratically, and I basically came to the conclusion that I didn't have a good zero. You know, none of this, I guess I should say that, none of this ammo was perfectly zeroed. The closest what that was zeroed was the H4831 shortcut handload, but everything else, you know, so I kind of zeroed that, and then everything else was, you know, in a different place, and I just told my app where it was approximately. So it didn't have a great zero, but the Outfitter, for whatever reason, that zero was screwed up, so I ended up having to go check that zero and come back and shoot it on a later date when I was verifying the 28 Nosler for Dale, and I don't have video footage of that because I was kind of in a hurry that day, so I didn't record everything. What else? And then I started out by using the Hornady 175 ELDX Precision Hunter ammo to kind of bracket the wind and figure out what that was doing. So I spent some time shooting the plate with that just to figure out what my bookends were for wind, and then I started the actual testing. So when we start shooting here, you'll see that there's already some hits on steel because the gun was shooting really flat, but I was just trying to see, you know, basically what the wind was doing. So that's all. So now we'll get through the shooting sequence, and then all the testing, and then we'll come back and review the groups at the bench. All right, get a good bearing on the wind again, and we'll shoot our first group. There's a 17. About 1 MOA wind. I'm not gonna wait for it to change. I'm gonna get a group down there. $3,001, $3,002, $3,031. Go
we'll see how we did. Let's see how we did. 175 ELDX and 7 PRC. You know, shooting all this ammo on the same day, we did not have a good zero for any of these, but we'll see how we did. And you know, we care when we're testing ammo like this, we care more about the vertical at distance, because that tells us how the load's performing. Ooh, baby. The group size is important too, but you know, this left and right, that's more the wind than me, so we care more about the vertical. What do we have here? Holy crap. What is that? 1.5 inches of vertical? It's like 1/4 MOA of vertical. And then that's really good. What's a group size here? Or center hole there. 3 7/8 inch group. That's really good. All right, we went down, got a look at group 1 for the 175 ELDX. That was fantastic. Let's see how group 2 goes. Get 1 or 2 on steel and shoot second group. Wind's still holding pretty steady. We'll load up 3 more. Get another group down there. So far, 7 PRCs living up to the hype, but we'll see how we shake out. All right. Now we'll see how we do with our slower 78-28 hand load. Start with that. Won't have a lot of extra ammo with this, so we're going to have to be efficient. A little bit downwind from our initial guess, but again, we didn't have good zeros with any of this ammo, so not too bad. Elevation's pretty good. Wind's about 1.5 minutes. We're gonna go with that. These last two shots were 29.70 and 29.69. It ain't good. All right, first group. See how we do. I have a feeling that one's going to be good. 29.74, 29.71, 29.72. Well, it looks like, it's hard to tell from here, but it looks like one of the shots is even in the orange bullseye. But it's tough to see. It could be a fly too. While the getting's good here on group 2. I got a good bearing on the wind, and I don't have a ton of extra ammo to keep track of the wind, so get these down there. $29.85, $29.80, $29.75. Pretty good. That ES was 10. ES on the group before was only 3. you know, not crazy performance as far as velocity. We're like 100 feet a second under what the factory ammo's doing, maybe more. All right, now we're on to 4831, and we have very little extra ammo for this one as well. Hopefully we're right on the wind here. Don't have a bunch of screwing around. We'll put some groups down there. Pretty good. A little bit upwind and a little high. Just done the same thing without changing anything. Elevation's good. I know where we're at for wind. Shoot some groups. All right, we'll see how we did.
All right, well, that was an excellent day of shooting. Overall, the rifle performed incredibly well. I can't say the same for all of the ammo, but we'll go into that and we'll look at each group and how it shot, and then we'll do kind of a little summary at the end and kind of put a bow on this, since this will be the last of the testing with this rifle. So I think we'll jump into the screen recording right away. 3, 2, 1, and we're live. All right, so we'll do this, the Hornady Outfitter 160 grain CX ammo first. You can see here I was trying to put everything on paper, and for whatever reason I blew the wind call on this group, so it went on 2 different sheets. I don't recall if it picked up or died off, because I shot this a couple months ago, 2.5 months ago now probably, and I'm just recording the review portion now. But at any rate, that's not the important part. I'm going to go through this and kind of explain to you what I look for and what's important to me, and what you guys, in my opinion, what you guys should be looking for when you test ammo at long range. Because you're not looking for the things necessarily that you've been told or think you should be looking for. What I look for, I think, is more important than a lot of the things you're told you should be looking for. We'll go into that. So first group, with all these ammos, I basically put 1 to 4 shots on the steel, and then went over and shot the groups. And just did 2 groups of each, so we have more of a sample size than one, but because we're shooting so many different guns and so much different ammo, that's why I limited it to 2 groups per ammo. Not because I think that that's adequate testing, but just it's enough to give us an idea of what the ammo is doing, so you can know what to look for, and I can explain to you guys what I look for, so you can go out and apply it to your own testing. So, first group, 30-80 average, SD 10.5, ES of 24, and that extreme spread of 24 feet a second theoretically accounts for 1.16 inches of vertical. Just that velocity disparity. In my experience, I have not found that to be true or relevant, or however you want to say that. And you'll see why. The group overall, which I don't really care about, but I put it on here because I know some people are going to be curious. To me, the group doesn't matter really, unless you're trying to test your own skill and wind reading ability, which is not what I was doing for this. I was basically just heaving them down there, trying to make sure I caught them on paper so we can measure the vertical, and trying to make good shots and control my vertical, because to me that's the most important thing that we're looking for. The vertical on this was 5 3/4 inches, which worked out to 0.858 minute of angle. But because we're shooting 640 yards, a minute of angle at that distance is 6.7 inches. So you can do the math yourself and figure out this MOA, but I put it on there for you. And then later you'll see what else I'm looking for, which is probably the most important thing. Second group was much worse. This actually hit 3 different sheets of paper. No bueno. You see why, like, if you don't have a good zero and this is how it's shooting, you see how it can be kind of tough to figure out what it's doing and like try to catch everything. Remember, at 100 yards it was shooting like 1 1/4 MOA, or 1.1 to 1 1/4. I think it started out shooting really good, and then every time I shot it, it got worse. So 30-69 average, just pretty similar to the last one. 30-80, SD 15.1, ES of 36, which is theoretically worth 1.76 inches of that vertical. Overall group was 12.07. If it was centered up, you're going to hit an elk, no problem. Even this, like, let's say this orange circle was where you would want the bullet to be, he's probably still in trouble with any of these shots, but not ideal. And then the vertical was 7.188 inches, which works out to 1.073 MOA. Why is this relevant? Well, now you guys are going to learn about my vertical grading for viable long-range ammo. If you watched the entirety of the 22 Nostr series, you already know this, but I mentioned that I was going to be bringing it up in this series, and here it is. So, for me, when I'm trying to evaluate ammo, whether it's a hand load or factory ammo or whatever, in order to be what I would call reliable, and you've probably heard me mention in the series many times, like having good equipment and that's consistent, and having ammo that's consistent enough that you're getting good feedback. This is what I'm talking about. Where, like with this outfitter ammo, you see, we'll go through all this, but I'll skip to the bottom here. The real VMOA average, so the real vertical minute of angle average, with the amount of shift that it had, was 1.414 MOA, which over 1 MOA is unacceptable. Why? Well, you saw the groups that it shot. The one group was small enough that you're like, oh, that's not so bad, whatever it was, 5 or 6 inches or whatever the number was. And the other one was 12 inches. It's like, that's not the end of the world, but when you combine it with how much vertical you have, plus how much it shifted from one group to the next, plus when you're out in a hunting environment, you're probably not going to get an exact range. Your range is going to be wrong for whatever reason. Like, all these things compound, and then pretty soon, you're just as likely to miss the animal as hit it. So, and when you're practicing, when it's that erratic, when it's over 1 MOA of vertical average, to me that's unacceptable, because you're not getting good feedback. when you go out and practice and you make a shot and let's say the bullet goes right where you're aiming, and then you make another shot and it goes 6 inches higher or 5 inches higher, and you didn't do anything any different, you think you did something wrong, and the next shot you didn't do anything wrong either, and it goes 5 inches lower. Well, now your group's 10 inches tall and you're doing everything right. Like, now you're chasing your tail. Now you're thinking that you're doing something wrong, and you're getting horrible feedback. So when a gun shoots like that, it ain't good enough. You got to do something else. You got to get better ammo or reload, hand load, or whatever. So go through this first, and then we'll go through my grading system. 3074 was the total average for the two groups, SD 14.1, ES of 36, which is 0.263 MOA of vertical at that distance, theoretically. The vertical MOA average was 0.966, so almost 1 MOA average of vertical. But from group to group, the center of the group shifted 0.448 MOA. So from one group to the next, like one group was here, I had that big rectangle plate. I measured from the top of the plate down to the center of the group, and then shot another group, and it was almost half an MOA lower. So it's not just about the group size, and it's not just about how much vertical the group shoots. It's from group to group, how much is it moving around, and that's why maybe we derail here and talk about this. That's why with my abbreviated load development method, the 10-shot method, that's why I care about the bullets, the sequential charge weights hitting in the same place, is that I want to know, like, across a certain velocity band or across a certain temperature band is the same way of thinking about it, because that's what you're checking. When you have multiple charge weights in a row that hit in the same place, that's the same as the gun shooting in the same place at different temperatures. There's no difference. So when you have sequential shots in a row that hit in the same place, that means that whatever hand load you find at the center of those charge weights is more likely than not to not have a lot of vertical shift. Now, you can still get vertical shift, but in my experience, doing it that way, actually being concerned about where sequential charge weights hit relative to each other, more times than not, if you do that and you make that a priority, more times than not, the vertical shift of the ammo is going to be very minimal. And that's what you want, because you see, like, this ammo didn't shoot well, but you'll see in later examples, sometimes the vertical shift can be just as much as the original vertical average. It's like if it averages this and it shifts the same amount, well, now you're twice as worse off on my grading system. And your group is, theoretically it's twice as high, because if it's this big but it shifts the same amount, well, now it's double. It's not what you think it is, it's double. So you need to be checking this stuff. It's really important, and it can do horizontal shifts too, but that's a lot harder to see because of the wind. Because the wind varies constantly. If you have like a half MOA horizontal shift, depending on your cartridge velocity and distance, a half MOA, the way that's going to show up at distance, that might only be like 1 mile an hour worth of wind. Well, that's going to get lost. You're never going to see that. Where, like I said in the series, the vertical shift you will see. And that's why I don't like tall groups, and I don't like necessarily picking sequential charge weights that are close to each other but different vertically, because sometimes that can spell disaster by the time you actually stretch it out. So we'll look at my grading system here. Again, vertical grading for viable long-range ammo. In my experience, and from what I've seen online, I feel like this is pretty accurate. Over 1 minute of angle, unacceptable. Not over 1 minute of angle group size. We're talking just the vertical. Frankly, I don't really care about the group. 1 MOA to 0.8 MOA, acceptable. Where that's like the minimum. That's the baseline. It's got to do at least that, otherwise you're getting bad feedback. And your practice is kind of a waste of time. 0.8 to 0.6 MOA, I would call good. That's, let's call it really good factory ammo or a decent hand load. 0.6 to 0.4, I would call great. That's a really good hand load. 0.4 to 0.2, that is exceptional. Because then you need not only something that shoots, approaching 3/8 of vertical at distance, but it also can't have any shift, or it's got to shoot in the 0.2 to 0.25 whatever of vertical and have minimal shift. Getting those two things together is a lot of work, and you got to do most of your load development at distance and test all your things at distance, and then you got to be. You talk about when I said you can't make any mistakes, then you really can't make any mistakes, because one shot can put you from exceptional to unacceptable or barely acceptable. You know, it doesn't take much. So you got to do it repeatedly, and you got to do everything perfectly. And then sub 0.2 MOA of vertical, I just call rare. That's rare past 300 yards, but necessary for short range bench rest. Short range meaning 100 and 200 yards. If you want to be competitive at short range bench rest, you need to shoot sub 0.2 all the time. So, so that we don't really expect to see with big game ammo of any sort. I would say this exceptional down to acceptable is where you should plan on trying to get to. Don't try to get it down to the rare, because you're likely not going to. You might burn out a barrel before you actually find a load that'll do that. So this is going to be our grading system for the rest of the series, and this is the grading system I use to evaluate ammo, because, you know, if you shoot a small group at distance, it's like, well, that's a small group, you know, or you say, okay, that's a 5-inch group. Well, a 5-inch group that's all vertical and a 5-inch group that's all horizontal are two very different things. The 5-inch group that's horizontal but it's only 1 inch tall, I will take that 100 out of 100 times over the one that's 5 inches vertically, but you got the wind right on every shot, or, well, you know, whatever. You want the gun to shoot flat, because what that's going to do is allow you more range error and allow for more variables up and down, and then all you really have to worry about is the wind. So that's going to be our grading system going forward. You know, and I guess what I was getting at was, you have to start putting benchmarks. You can't just say, okay, well, that's a good group. Well, define good. You know, you got to start putting lines in the sand, like, so you can grade these things. You know, that's what this is. It's a grading system. All right, so I put this little slide here. We're trying to test this at 640 yards, right? And we're trying to stay under 1 MOA of vertical. Well, this is not. It's 1.414. So if this is no good for 640 yards at basically sea level where I am, how far is it good for? Take you guys back to math class. All right, so if we know the range we tested at, 640 yards, and we know how much the real vertical MOA average is, and we say, okay, if we want to be at least to that 1 MOA benchmark, and you can put whatever MOA you want over here, to figure out the range limit, you take your distance, so your tested range, times your desired MOA, divided by your actual MOA, your tested MOA, and that gives you the theoretical distance that this ammo would have held 1 MOA of vertical. Including the shift. This is what I just showed you. This formula assumes that dispersion is linear, which I already told you that it's not, but this is better than nothing. So if you shoot something and the group's way too big, and you're like, okay, well, how good is, I don't have time to mess with the ammo. How good is this ammo? How far is this ammo good out to? You can use this formula to get a ballpark approximation of where you need to move the target to continue your testing, and then see, okay, so you move it down to 452 yards or 450 yards, and then see what kind of vertical it holds with what amount of shift, and hopefully that stays under 1 MOA. So you at least know what the ammo is good for if it's not good for the distance you tested it at. All right, and then we're on to the 175 ELDX Precision Hunter ammo. This shot a lot better, but still had the factory ammo, erratic things about it. So first group, 3011 feet per second, and this was the original lot that they came out with that was really fast. I'll probably do a video on this at some point in the winter, but we tested 3 or 4 different lots. I think 4 different lots of this ammo now at this point, and they all shoot, all of them. I think we had one lot that was 2880, which is where I thought we would be. If you remember the initial intro video, I thought we would be at 2880. One of the lots we tested was there, and it shot amazing, like half-inch groups. And then another lot was, I want to say, 2930, 2920, and that was using a different color primer than the 2880 or the 3011, and that still shot a half-inch group, and the point of impact was the same across all 3 lots. And I think the 4th lot was like 2950, and same deal. I don't remember the primer, still shot a half-inch and a different velocity and hit in the same place. So like 4 different lots, all the same point of impact, all shot a half-inch, different primers, different velocities. Like, you guys can say what you want about their ammo, this stuff is legit. So shot really good. It didn't shoot as small a groups ever as that Barnes LRX ammo, you know, but that was shooting some big groups and some tiny groups, kind of yo-yoing. This Precision Hunter ammo, it didn't matter the lot, everything shoots like 3/4 to half-inch. Not smaller than a half-inch, but not really bigger than 3/4 either, and same point of impact, no matter the velocity, like different primers, whatever. So it's good stuff. But this stuff, okay, so confession time on this Precision Hunter ammo, that was the hot stuff, that was over 3,000 feet a second. We actually ended up sending back like 16 boxes to Hornady to have them replace it, because I think across 2.5 boxes of testing I did with that ammo, I think I blew like 15 primers where they were so overpressure, or the brass was so soft, or a combination of both. I don't care. When I eject a spent piece of factory ammo on the first firing and there's no primer in it, something's wrong. Okay, it's either way overloaded or the brass is too soft, or both. So it blew like whatever that is, 20% or better, 20 to 25% of the primers. So we had, you know, almost 2 cases of it left, so we sent it back and they replaced it. They didn't say if they tested it and what their findings were, but they replaced it, so that should tell you enough. Anyway, so first group, 3011, SD 13.9, ES of 30, which in theory is worth 1.9 inches of vertical. Group 3.938 inches from center to center. And all these groups, when I got home, I poked a pen through just to try to make them a little more visible for you guys, make the holes a little bigger. So you'll see some of that. Just under 4-inch group, which is awesome. But look at the vertical, 1.375 inches of vertical. That is outstanding. But look at our extreme spread. So how, if everything works the way you guys have been taught that it does, and ES is so important, how is this ES worth almost 2 inches of vertical, but the group is 1 3/8? Explain that to me. I'll wait. I see this kind of stuff all the time, where the ES doesn't match the vertical. The ES is way bigger than the vertical should be. I know a lot of you guys watch Eric Cortina. If you remember when he shot that, I think it was like a 5-shot group at 1,000 yards, and it was like 1 3/8 or something like that for a 5-shot group. And it was, I think the 1 3/8 was pretty much all vertical. I think he said his ES was 28 or 29. So the group should have been 3, 4, 5 times that height, not 1 3/8. It should have been whatever, just because of the ES, but that's not how this stuff works. That's why you got to take it out and shoot it at long range and see what you actually have. Don't get lost at 100 yards. I'm going to drill that into you today. So 0.205 MOA of vertical. If you remember from our grading system, That's exceptional, at the bottom of exceptional, if it can do that repeatedly. Repeatedly being the key word. Second group, oof da vida, 2988, so whatever that is, 23 feet a second slower. Average, not good. SD 16.7, ES of 41, which is, I don't think that would be worth 1.9. I must have forgot to change that. No, that would be worth more than that. I must have forgot to change that. A lot to change on each of these. Anyway, group 8 3/4 inches, and the vertical was 8.563. No bueno. Which works out to 1.278 MOA vertical. My word hole is getting dry. So, this is why we shoot more than one group. You guys should shoot a lot more than 2 groups, but I already told you why I did 2. When you average them together, here's our summary. The average, so this is important, the average was 3,000 feet a second, SD 19.2, not good, ES is 63, which is worth 0.470 MOA vertical. Yuck. Theoretically. The total vertical was 0.742. That was the total vertical average between the 2 groups. Remember, we had one awesome and one huge. And it had only 0.112 MOA of shift from center of group to center of group. They were almost identical. So you add those 2 together, our real vertical minute of angle average is 0.854, which is comfortably in the acceptable category. So this is perfectly acceptable. I think if I shot more groups, this is what my gut tells me, if I shot more and more and more groups with that ammo, this real VMOA average would come way down. Might even come down, it would probably come down into the good category, but I only shot 2 groups, so that kind of sucks for this ammo. But either way, my point is, whether it's acceptable or I shot more groups, the ES probably wouldn't get any worse than that. It might even fall into the good category. And look at the ES. You know, you guys are being told you got to have this great ES, and you know, in my technical videos I showed, all right, well, let's assume our ES is 50, because out to 600 that doesn't matter. And that's 600 in the mountains, it doesn't matter. This is 640 at sea level, which is like 740 in the mountains. And still, despite that, ES is 63, still acceptable factory ammo. That's why I'm telling you guys, don't get lost on your frickin' load development. Pouring over metrics at 100 yards. Oh, well, it doesn't do this, and it does do that, and it has to shoot this size group all the time, and I gotta get my ES down to whatever. It doesn't mean shit. Go stretch it out and see what you have before you waste a bunch of time on your load. Because this, I would feel totally, you know, I already told you in the LDX I don't like for elk, but for deer, if this was a 300 to 600 yard deer load, I would be totally comfortable using this ammo. It shoots that good. But, you know, ES 63, oh, that's garbage. You know, that's totally not usable. Well, the first group you saw was like, what, 1.5 inches of vertical with an ES of 30 or whatever it was? I mean, totally fine. Get out and shoot. So, again, perfectly acceptable. Now, we'll move on to the hand loading portion of this adventure. First group with 7 PRC H4831 shortcut, 160 grain CX. Group 1, oddly enough. This is why ES, another point why ES is not everything. This is going to blow your hair back, and if it doesn't, somebody should check you for a pulse. Average 3042, SD 0, ES 0, worth 0. Group 4 1/4. Vertical 3 5/8. Fantastic. 0.541 MOA of vertical. Now our next group, drum roll, For those playing the home game, that's an 1.5-inch group at 640 yards. With an ES of 35. Camera 1, ES is 0, 3.625 of vertical. Camera 2, ES of 35, 1.063 inches of vertical. 1.16 inches. ES of 35. You guys keep wasting time at 100 yards trying to get your ES down. You go right ahead. I'll be out here shooting at long range. Learning how to read wind, something valuable. Not wasting my time at 100. Again, just to pound it home a little bit more. ES of 0, 3 5/8. ES of 35, 1. Which works out to 0.159 MOA. Now, this ammo is not going to shoot like that all the time. This is an anomaly. This would be on the small end of the bell curve, you know. The rare, you know, very, very small end, but it did it. So, I don't know what to tell you. If I shot more, obviously my average is going to be a lot bigger than that, but this is what happened. So, and then our summary and grading, we had a 30-51 average, SD of 13.5, ES of 37, which is in theory worth 0.273 MOA of the total 0.350 MOA, which I don't buy. And this had almost no vertical shift. This is about the best you can hope for. Less than 0.1 MOA of vertical shift between groups. That is fan-frickin-tastic ammo. So our real vertical MOA average, you take 0.350 plus 0.093, we get 0.443 MOA, which is very comfortably in the great category, and had it not shifted, it would have been in the exceptional category. Damn good stuff. Who's surprised? Not me. Remember how small that ag was when we did our 10-shot ladder? That's a good point too. I'm glad I brought that up. So, because I don't have notes on this one, it's just, I'm winging it. Remember when we shot the 10-shot ag, how small that was? It was like, the 10-shot ag was like an inch or something like that. Well, that's why I said, like, whichever ag shoots the smallest, that's probably the powder you should pick. This is why. Because if the whole ag for almost 4 grains of powder was an inch, how much vertical shift do you really think you're going to get? Especially if inside of that inch you pick sequential charge weights that hit in the same place. How much vertical shift do you think you're really going to get? You know, that's the thing, is that the vertical shift is what can kill you and what can throw your ammo from acceptable to unacceptable. So that's really important. All right, so that shot amazing. Now we're on to 78-28 super shortcut. This shot really good too. This is a lot like that first group with the Precision Hunter 175 ELDX ammo. And remember I said I thought one of the bullets hit the orange? It did. It was on the bottom edge, but it did hit the orange. This was much slower, 29.72 average, but the velocity metrics are bonkers. SD 1.2, ES 3, which is worth 0.160 inches of vertical. The group was 6 3/8, which I don't really care about. And then the vertical was only 1.5 inches. 0.224 MOA. Damn good. In the exceptional category. Second group, 29.80. So what was this one? 29.72. Really consistent. I think this had the best velocity metrics for the day. SD 4.1, ES at 10, which in theory is worth about 1/2 inch of vertical. Group was 6.813, which again I don't really care about. Vertical only 3 1/4. Really good. 0.485 MOA. So we got 0.485 MOA, 0.224 MOA. You're thinking that's fantastic, but look at where the groups are. The center of the group is kind of down here. Look at where the center of the group is on this one, up here. on the opposite end of this orange oval. Well, I didn't do that. If you watch the video, I didn't add any elevation. Now the barrel was hot, but the velocity was almost identical, so that I don't think that's it. That's why you got to test this stuff and shoot multiple groups and actually measure the center of the group to see how much vertical shift you're getting. So what should have been whatever that is in the 0.3s average, 2976, SD of 4.9, ES of 14, which in theory is worth 3/4 MOA. That can't be right. No. Yeah. No. That wouldn't be right. No, that's not right. That must have been from something else. I got a few mistakes on here. Oh well. The average vertical between the two was 0.355 MOA. That's probably supposed to be 0.075. Vertical shift, 0.345. Do you see that? See why that's important? Like, you got ammo that shoots great, but from group to group, it's shifting 1/3 of a minute of angle. So you got to add those two together. You got to add the average plus shift. So that puts us at an even 0.700 MOA, which is still in the good category. Not the end of the world. But you see, like this one, the ES is 14, but because of the shift, it's just in the good category, where the H4831 ES was 37, 2.5 times what the 7820 was, and it's in one category better because it didn't shift. So vertical shift is more important than ES. Take it to the bank for this application, not for ELR, not for, for hunting out to 600 yards. Vertical shift is way more important than ES. All right, what are we on to now? So just to recap, over 1 MOA unacceptable. That's where the outfitter landed. The 175 ELDX Precision Hunter landed in the acceptable category. The 160 CX handload with 7828 landed in the good category because of the vertical shift. Should have been in the great category. Borderline exceptional category. Oh, actually it was in the exceptional category until it shifted. Same with the 4831. That was in the exceptional category without the shift. And then H4831 shortcut ended up in the great category, not exceptional because of the shift. So got to shoot more than one group. You got to shoot multiple groups. You can't just take it out and produce one group. Like what if I would have shot one group and it was with 4831, it was that 1.5 inch group. And then I go running around. Oh, this is 1.5 inch at 640 yards ammo. Well, it's not really. It can do that, but that doesn't mean that that's what it shoots all the time. So you got to shoot more. And then we'll go into our load development summary. So this is, remember we were talking about our linear path. There's a lot on this, so we'll walk through it. And I think that was my last slide. So with Hodgdon 4831 shortcut, our total load development was 31 shots to find this load. Long range verification, 8 shots. 2 to kind of make sure I had an idea what the wind was doing, and then I just shot the 6 shots for groups and shot them back to back. So 39 total shots fired to find a great load by my standards. 39 total shots, and I found something that shot whatever it was, 3.25 inch of vertical and 1 inch of vertical. Unreal. Average velocity 3051, standard deviation 13.5, extreme spread of 37, real vertical MOA 0.443, which is in the great category. IMR 7828 super shortcut, total load development 16 shots, long range verification, that one I shot 9, where I did 2 for wind, shot a group, 1 for wind, shot a group. 25 total shots fired to find a good load by my standards, which would have been exceptional except for the shift. And this is something that maybe you can test different seating depth or, play with different things to try to eliminate that shift. But I feel good about the shifts that these had, meaning I think it's good data because they were all shot by me using the same equipment. The outfitter was on a different day, but the 4831, 7828, and the Precision Hunter, those were all shot on the same day with the same equipment. So, however much they shifted, that was the ammo, not me. And then, average velocity, 2976. Standard deviation, 4.9. Extreme spread, 14. Real vertical MOA, 0.700, which is in the good category. Again, just turned out really good considering I only had 25 shots invested total. Hornady 160 CX outfitter could have been tested with one box of 20, between shooting 3 groups of 3 at 100 yards and then going out and checking it at long range. As long as you had a good zero, you could do this test that I just showed you guys. Shoot 3 groups at 100, get a good zero, go out, check the wind. As long as you're on the plate and you got an idea what the wind's doing, you could put the shots on steel or on paper, either one, it doesn't matter, and get an idea what kind of vertical it holds and if it shifts between groups. Long range verification ended up unacceptable. 1.414 real vertical minute of angle. Average velocity 3074, so you see that was probably 23, average was 23 feet a second faster than our fastest hand load. SD 14.1, ES to 36, almost identical to the H4831 shortcut hand load. But our real vertical MOA 1.414, unacceptable. Hornady 175 grain ELDX Precision Hunter, could be tested with one box of 20, again. Long range verification, acceptable. Comfortably. 0.854 real vertical minute of angle. And again, that one had one that was whatever it was in the exceptional, 0.205 in the exceptional category, almost to the rare category, but then had one that shot really poorly. So, and you're more likely to see that with factory ammo. So, long range verification ended up acceptable, 0.854 real vertical minute of angle, average. Average velocity ended up being exactly 3,000 feet a second. Standard deviation 19.2, extreme spread of 63. Real vertical minute of angle 0.854, which is acceptable. So that's it, boys and girls. That's it for the 7PRC. So what we found is that the load development method I showed you guys is perfectly adequate for finding a load that can suit your needs and can check the boxes if you're willing to keep your shots within reasonable ranges. And then our factory ammo, the outfitter ammo, just it ain't gonna cut it. Not for the distances we were shooting. Does that mean you can't use it at all? No, but like I showed, maybe around 450 and at low elevation is where that is better suited, 450 and in. And maybe with different lots it'd shoot better, but from what I'm hearing online from all you guys and all over, nobody's really having much luck with that 7PRC outfitter ammo. It just doesn't shoot that great, which is too bad because it's a great bullet. We really like the bullet, but if it doesn't shoot, it doesn't shoot. And then the Hornady 175 grain ELDX Precision Hunter ammo, that stuff shoots incredible. Now that I've had time to play with it and test a bunch of different lots and multiple different guns, and that stuff shoots really good. Like I said, if I shot more groups at long range, I think our average vertical would have come down, but our ES was already really high. Could it have got worse? Yes. Does that matter? Not really. I think it's more about what kind of vertical it holds. But overall, I think that's what they have going on there is working. That's really good factory ammo. Again, I really don't like it as an elk or a moose bullet. I know guys use it and whatever, but I think it'd be perfectly acceptable mule deer, pronghorn, whitetail ammo, even at the velocities it's pushing it at, because even if you're shooting it at short range, I think the velocity is going to be low enough that the bullet should hold together for the most part. But the big takeaway, I guess, is you see what I was able to produce here with minimal load development. Now, I have other methods that I'm going to show you that are more involved, that are more close to what the average person might do. I'll show you guys that in the hand loading series that's coming up. But for a big game load, with how big the target is and how high a performance bullet and cartridges we're using, the method I showed you guys is perfectly adequate. So don't waste all your time at short range, because I've had loads that shoot a really good ES and they shoot really small, and you take them out at distance and they just don't shoot, or they have a big shift or whatever. Like, you don't know what you have until you actually get out and test it. So I hope that's what came through with this. So next, I think we're going to be doing the video on probably the 28 Nosler, just because I have all that done. But I'm not sure yet. So next will be another one of these long range videos. Well, actually, we're going to do all 4 of them now, and then we'll start doing our summary conclusion videos where we have all the data and compare everything side by side and see, you know, when you go to a bigger cartridge or smaller cartridge, like, what are you gaining, what are you losing, and go into all of that. So so thank you guys, I appreciate it. Thanks for your patience. Like, subscribe, share with your friends, all that good stuff, and we'll see you on the next one.